Yes.
Okay.
Yes.
So we've been going through chapter 4, and this work has not been that difficult. Section 4.4 is really not that difficult either, other than we're adding and subtracting unlike fractions. So the unlike fractions would be fractions that have different denominators. And we know from elementary school that when we need to add or subtract fractions, we must have denominators that are the same. So in order to achieve this, you need to find the least common denominator. Now, you had some practice with this in the last section that you did. Those were the last few problems. But we're going to go through and maybe give you a different way to do it. I'm not sure. So if you have just two numbers, like we have 2 and 3, you check and see, does 2 go into 3? And no, it doesn't go in there evenly. So take the largest number and go up the next multiple of it, which is 6. And see, does 2 go into 6? Yes, it does. So that is our least common denominator. When we have three numbers, 5, 4, and 12, we're going to look at the 12 and say, does 4 go into 12? Yes, it does. If it already goes in there, then we don't need to ask about 4 anymore, because anything else beyond that, the 4 will go into. Does 5 go into 12? And no, it doesn't. So I go to the large number and I go up a multiple of it. So I'm just going up by 12s. Does 5 go into 24? No, it doesn't. So I go up another 12. Does 5 go into 36? No, it doesn't. Does 5 go into 48? No. Does 5 go into 60? Yes. So,
Yeah, it does.
It does.
It does, yes. So our least common denominator is 60. So 5 goes into 60 12 times, 4 goes into 60 15 times, and 12 goes into 60 5 times. So that's one way to do it. And if we continue this out, 14 doesn't go into 35. But when I move up to 70, which is the next multiple, 14 does go into 70 5 times. So we found those least common denominators.
Are you still supposed to be wearing pants?
And once we find the least common denominator, we need to convert each of the fractions so it has that as the denominator. During this conversion, we don't want to change the value of the fraction. What do I mean by that? If I had 1/2 plus 1/3, and I just said, oh, my least common denominator is 6, so I need to add 1/6 plus 1/6. I've changed the fractions there. I multiplied the denominator by 3, but I didn't multiply the numerator by 3. When I do that, I get a fraction of 3/6. 3/6 reduces down to 1/2, so I can see that those two are the same fraction. 1/3 and 1/6 are not the same fraction. So 3 times what gives me 6? And that's 2, so 1 times 2. Now when I do that multiplication of the numerator, now when I look at the 2 6, I can see, oh yeah, that simplifies down to 1/3. So what I'm really doing here in this process is multiplying the numerator by 3 and the denominator by 3. And 3 over 3, if I were to reduce that down, what does that reduce down to?
1.
Yes, it reduces down to 1. And when you multiply anything by 1, do you change its value at all? No, you don't. So
Nope.
I have converted those fractions. Let's look at this fraction, or this addition. This is the second one that we found, and we found that the least common denominator was 60. So I'm going to put 60 as the denominator for each of my fractions. We said 5 times 12 gives us 60, so 3 times 12 is 36. 4 times 15 gives us 60, so 1 times 15 is 15. And 12 times 5 gives us 60, so 5 times 5 is 25. So we've converted those ones. Now, after we convert, what do? We add them together just like we did in the previous section and reduce it down if possible. So 3, 6 plus 2, 6 is 5, 6. Does that reduce down? Nope. So that's our answer. We look at these numerators. I'm going to add 15 and 25 first to get 40. And then 40 plus 36 is 76 over 60. And that reduces down. If I take a 2 out of each of them, I get 30, 3. No, 38. 38 over, what am I doing, guys? 38 over 30. Taking out I'm reducing it down by 2. They're still even numbers, so I'm going to reduce them down again, and it's going to be 19 over 15. Now, your calculators will do what? It will take this 3/5 plus 1/4 plus 5/12, and it will give you this answer right away. You guys still need to know how to go through the conversions and how we go from a common denominator of 60 to get 15 to be our denominator in the end. So you need to know that whole process, even though your calculator is going to do that for you. You still need to know whether or not your answers are reasonable. So this is one way your calculator will display it. The other way your calculator will display it is 1 over 4/15. So either one of those I will accept as the answer unless I say specifically to convert it into a mixed number. All right. So in order to find the LCD of larger numbers, remember the factor trees that we used to talk about in elementary school?
Yeah.
Okay,
Yeah,
so
I remember those.
So let's look at how that looks with our lesson. I'm going to use the numbers 360 and 420. We see that both of them end in 10 and 0, so we can pull out a 10 out of each of them. So 10 times 36, 10 times 42. And then we break down 10 to be 2 and 5, and 36 to be 6 and 6. And then each one of these 6s reduces down to 3 and 2. And if I go over here, it's same thing, 2 and 5. This one is 6 and 7. And this one is 2 and 3. So we're trying to get prime numbers at the end of all of our leaves. And we're going to write these prime factorizations in terms of bases and powers. So 360 is the same thing as 2 to the 1, 2, third power. There are 3 2's there, so we're going to write it down as 2 to the third. We have 2 3's, so that's going to be 3 to the second, and we have a 5. So if we were to take 2 to the third power, 3 squared times 5, we would end up getting 360. For the 420, it looks like 2 to the second, 3, 5, and 7. So once we have them written out that way, we get our least common denominator by taking each of our bases that we have. So we're just going to write down all the different bases that we have in combination with all of them. And then we're going to take the largest power that we see on that base. So we have 2 to the second and 2 to the third. So we're going to take that largest power and put the 3 up there. The largest power on the 3's is a 2. The 5's, each of those powers is a 1, even though you don't see it there. So we're just going to have 5 to the first. And this one, you have a 7 to the first, but you don't have a 7 up here. That's all right. If you see it, it has to go into the LCD. So it's 7 to the first. This actually up here, just so you know, is 7 to the 0th power if we have that base up there. So 1 is larger than 0, so that's why we're putting the 1 there. And then if we multiply this out, 2 to the third is 8. 3 squared is 9. 5 and 7. So what's the difference between the 360, I'm going to erase that, 360 and our least common denominator? There's a 7 at the end. So our least common denominator is 360 times 7, which is 2520. So we've got larger numbers. They don't even deal with larger numbers in this section. They keep everything simple and they're small numbers, and you probably can figure out the least common denominator by just doing it in your head. And that's all right. If you can figure out the least common denominator by doing it in your head, do it. I don't need to see work on your least common denominators. What I'm interested in is seeing work on how you convert the fractions and how you add the fractions together.